In this video, we're going to talk about how to graph absolute value functions and identify key characteristics. So today we'll be graphing absolute value functions such as f of x equals the absolute value of x and determining the key features of the graphs. So some of the key features we're going to be studying are domain and range, intercepts, symmetry, where the vertex is, and whether the graph has maxima or minima. So the vertex will be the highest or lowest point on an absolute value function. And this is actually very similar to when we talk about parabolas. If the absolute value function opens up, the vertex will be a minimum. If the function opens down, the vertex will be a maximum. So the axis of symmetry will be a vertical line about which the graph has reflectional symmetry. So it's really similar to parabolas. If you were to fold a graph along the axis of symmetry, both halves of the graph would match up. The axis of symmetry will pass through the vertex, so the x-coordinate of the vertex will help you identify the axis of symmetry. So for example here, you can see this graph has a vertex at -3, 0. So x equals -3 will be the axis of symmetry. So it'll be x is equal to whatever that x-coordinate of the vertex is. The x-intercepts will be where the graph crosses the x-axis, and when you're in Desmos and you graph your function, remember you can just click on those points to identify the x-intercepts. I wanted to identify the x-intercepts of the absolute value of x plus 3 minus 4. I could just go to Desmos, and remember from the keypad here, I could get the absolute value, and then I do x plus 3, and then remember I have to click outside to do the minus 4. Okay, so be very careful that you're putting the numbers inside or outside the absolute value depending on what function you're looking at. If I click on those 2 points where the graph crosses the x-axis, it gives me the coordinate. The x-intercepts are -7, 0, and 1, 0. Also remember we can identify the y-intercept because that'll be where the graph crosses the y-axis. You can also find this point by clicking on that in Desmos where the graph crosses the y-axis, and you can see here it gives me the coordinates 0, -1 as the y-intercept. So let's look at the absolute value parent function. Okay, let's look at the absolute value of x. And so I can go ahead and type that in Desmos. And let's identify all the important features of this function. So first, let's think about domain and range. So remember, domain is all possible x values. If I scroll around and if I look at this graph, I'll notice that it includes all real numbers as the domain, right? The x values never stop. So if I was going to describe the domain of this function, I could use interval notation, and I would say that it includes all values from -infinity to +infinity. So now let's look at the range. The range, remember, goes from low to high. So if I look at this graph, notice that it doesn't include all values of y. Okay, so the values of y, all these negative values, they're not included. And so the y values will actually start at 0 and then go up from there. Okay, so 0 is included. So I'm going to do square bracket at 0, and then it goes all the way up to +infinity. The x-intercept, well, I can just click on here and you can see the x-intercept is actually at 0, 0. And incidentally enough, that is going to be also the y-intercept, right? Because that's also where the graph crosses the y-axis. So the vertex, okay, that kind of corner point of my graph is also going to be at 0, 0. And so that means this graph has a minimum of 0 at x equals 0, right? Because that's going to be the lowest point on my graph. That's also the lowest y value. So it also has reflectional symmetry with respect to the y-axis, because remember, I can find the axis of symmetry. I can just take the x-coordinate of the vertex, and if I type in that line, I can do x equals that x-coordinate. You can see that creates an axis of symmetry. So that means this graph has reflectional symmetry with respect to the y-axis, right? Because that's what x equals 0 represents. So these are all the key features of the absolute value parent function. So let's graph f of x equals the absolute value of x minus 4 minus 3 and define its key features. So whenever you're doing this, you always want to use Desmos to help you out. So I'm going to go ahead and type absolute value and then do x minus 4 and then click outside and then do the minus 3. So you can see that the domain, the x values are going to be all real numbers if you scroll on this graph. So I'm just going to describe the domain as -infinity to +infinity. So for an absolute value function that opens up, the vertex is going to help you find the lowest y value. Okay, so if I click right here, you can see the lowest y value is going to be at -3, and then every y value is above that. Okay, so when I describe the range, I'm going to say square bracket at -3, and then it goes up to +infinity. For the x-intercepts, I'm just going to click on those points where the graph crosses the x-axis, and so the x-intercepts will be at 1, 0 and 7, 0. For the y-intercept, I'm just going to click on where this graph crosses the y-axis, and here it gives me the points 0, 1. The vertex is going to be that corner point of my graph, so I'm just going to click on that, and that's going to be 4, -3. That is the lowest point because my absolute value function does open up, so that's going to be the minimum. So it has a minimum of -3 at x equals 4, because the minimum value is going to be the y value because that's the lowest point of the function. Symmetry, it's going to have reflectional symmetry with respect to the axis of symmetry, right? So how do we figure out the axis of symmetry? Well, remember we use the x coordinate of the vertex. So it's going to be with respect to x equals 4. And if you want to see a visual of that, you can just always go ahead and type x equals 4 into Desmos and see that it does in fact cut your graph into 2 equal parts. So now you can go ahead and pause the video and try describing the key features of this absolute value function on your own. You can just use the graph in Desmos to help you identify the key features. We can see that the domain includes all real numbers for x, so we're going to say -infinity to +infinity. If we click on the vertex, we can see the lowest y value is -2, so the y values go from -2 to +infinity. The x-intercepts, if we click on them, we can see they are at -5, 0 and -1, 0. If we click on the y-axis, we can see the y-intercept, which is at 0, 1. The vertex is this corner point right here. You can see it's at -3, -2. And since this graph opens up, that is a minimum value. It has then reflectional symmetry with respect to x equals -3, because we can see that that is the axis of symmetry of our graph. So let's just do one more example. Let's graph f of x equals the negative absolute value of x minus 5, and let's define its key features. So here I'm going to go ahead and type negative and then use the keypad to get my absolute value, and then do x, and then remember that -5 needs to be on the outside. You can see here this looks a little bit different than the absolute value functions we've been looking at, because it does open down. You can see once again the domain is going to be all real numbers when you scroll around this graph. So the domain will be all numbers from -infinity to +infinity. When we describe the range of a graph that opens down, it's going to be a little bit different than a graph that opens up. Because let's think about it. The range goes from low to high. Okay, so this graph is opening down. So it goes all the way down to negative values of y. So that means the graph, the lowest point is actually going to be -infinity, right? Because it's starting all the way low at -infinity, but then it's coming up to a specific endpoint, right? It always comes all the way up to the vertex, and that's where it stops. So that means this -5, the y coordinate of the vertex, is actually going to be the highest y value. Okay, so that's a little bit different when you're looking at graphs that open down. The x-intercept, well, notice this is actually never going to cross the x-axis. Okay, so this one actually has no x-intercepts. And that's because the highest y value is at -5. Remember, the y value has to equal 0 for it to have an x-intercept. Coincidentally, that vertex is actually going to be the y-intercept. So it has a y-intercept at 0, -5. And we said that was the vertex. And since this graph opens down, that is going to be a maximum value. Okay, so it has a maximum value of -5 at x equals 0. Okay, for symmetry, it's going to have reflectional, okay, with respect to the axis of symmetry. Okay, so it'll have reflectional with respect to x equals 0, okay, which is the y-axis. And remember, we can always type it in. Remember, I found that x equals 0 because that's the x coordinate of the vertex, okay? If I type it in, you can see that it does cut my graph into 2 equal parts. Just keep in mind that the key features of absolute value functions will look a little bit different depending on what the equation of the function is. So we can graph absolute value functions to identify several key features of the graphs, and make sure that you're noticing these key features, which are the domain and range, intercepts, the vertex, the axis of symmetry, and whether the graph has a maximum or minimum.